Hello again. Today we take a look at Phuket Word's claim that flat Earth and globe maps are really the same. As a public service, I've added a handy facepalm warning meter to this video. Let's see what you've got, Phuket.
It's often assumed that when we navigate or measure distances on a flat Earth compared to a globe, that things should change, but they don't.
What's up with that map? Phuket says he has a, quote, working map, and then all we get are some preschool squiggles.
Observations and distances do not change. It's all a matter of interpretation.
No, Phuket, it's a matter of navigation. Distances and headings have to match. Notice how Phuket cleverly avoids using a recognisable map so we have nothing to compare it to.
So we'll just have a quick demonstration of this right here. Here I've got a map. It's a very simple map. All right. And I've got point A on this piece of land here and point B on this piece of land here. And if we measure the distance on this flat surface between the two, it's 9.5 centimeters. Okay. All right. So let's now get a ball. It's a volleyball, and
Phuket seems to have overlooked all the creases on his flat map as he wraps it over the ball.
Put this piece of paper on here, get our flexible ruler, and measure the distance again on this sphere between A and B. Okay? It's still 9.5 centimeters.
Well, of course the distance is the same between two imaginary cherry-picked points.
Okay? So, it doesn't matter. Flat or spherical. The distances between two locations do not change. Yeah? Same as this ruler. It's 30 centimeters long. You bend the ruler, it's still 30 centimeters long. It's really all a matter of interpretation. You can believe it's on a globe, or you can take it for what it is. Flat.
And here we have a textbook false equivalence fallacy. Phuket fitted a flat plane around a small section of a sphere and hoped we wouldn't notice all the creases as his map failed to conform to the 3D surface. Let's try that experiment using the most popular flat Earth map with 3 identifiable locations. The locations are the North Pole, Sydney, Australia, and Santiago, Chile. The reason for picking these locations is Qantas QF27, a non-stop Sydney to Santiago flight taking 12 hours 35 minutes and covering 11,340 kilometres. The flight path is entirely over the southern Pacific Ocean, as far as 70 degrees south. On the AE map, it's more logical to fly northwest and change flights in LA. But the recorded, real distance for that is 21,040 kilometres, and the time taken is 24 hours 35 minutes without transfer times. So what gives? Will Phuket's experiment show the distances are really the same? First, I scaled an AE map to have the same size as my globe and printed it. The AE map looks huge, but we will see the scale is the same shortly. Next, I cut out just the parts of the map with the locations and flight path. Now, let's stick the AE map locations over the same locations on the globe. Notice that the equator matches up perfectly, proving that the scale is the same. Santiago lines up perfectly. Maybe I should be worried. Let's line up Australia. That matches up as well, although the AE equator is at a strange angle. Maybe Phuket's right after all. But wait, the QF27 flight has detoured out past the ISS. How can that be? This is the false equivalence that Phuket hopes you won't notice. The distances and flight paths on the AE map and the globe absolutely do not correspond. Only a one-dimensional idiot would think a two-dimensional map can fit on a three-dimensional globe and still work. You lose, Phuket.